Good day, students. Welcome to part two of the clip on converting angles between radians and degrees, graphing, and also determining the reference angle. All right, we're going to be going over two questions in today's clip. Let's go ahead and write down the instructions for the notes. Uh, for given angles, we're going to do the following. Okay, A, we're going to express it in degree and radian forms, degree and radian form. And then for part B, we're going to graph the terminal side, and indicate what quadrant it lies in. And then for part C, last but not the least, we're going to find the reference angle. And express it in degrees and radians. Okay? All right, so those are the three tasks you're going to be completing for the given angles for today's clip. Okay, let's go ahead and take a look at question number one. So for question one, we have the angle theta. Theta equals negative 13 pi over 6 radians. Okay, negative 13 pi over 6 radians. Okay, so we can see that theta in this problem is given to us in radians, so we are expected to express it in both radian and degree form, so we have to express theta in degrees. So theta in degrees, in order to do that, we need to take negative 13 pi over 6 and multiply it by a conversion factor, okay? We have two choices. Either we multiply by pi over 180 degrees, which is 1, or we multiply by 180 degrees over pi, okay? So since we have pi upstairs here, which of these do we think we will select? Well, we want the pi to cancel out, so we're going to select the one that has a final position where cancellation will occur. So the choice that we're going to select is this option right here, okay? So we're going to multiply this angle in radian by 180 degrees over pi. All right? Notice what happens. This pi divides out with that pi. 6 goes into itself once and goes into 180 30 times. If you multiply across, you're going to end up with negative 390 degrees. Okay? So for part A, theta uh, equals negative 13 pi over 6 radians, or negative 390 degrees. Okay, so there goes our first answer. The second part is to graph the terminal side. All right, so part B, we're going to graph and indicate the quadrant. Okay, so let's make our coordinate system our x and our y. So let's make this our y coordinate, and then this our x coordinate. All right, so now let's look at the direction of rotation, okay? You always start from your positive x, which is 0 degrees, and you go up or down, okay? If the angle is positive, we're going to rotate upwards from the 0 direction, okay? We're going to go counterclockwise in that direction if it's positive. And if the angle is negative, we're going to rotate in a clockwise direction, negative direction, okay? Remember, every quarter of a circle is 90 degrees. Our angle theta is negative in this case, so that means we're going to be rotating clockwise, which is down and over, okay? We're going to keep going until we find two quadrants that, two axes that bound this value, and then this value is going to reside somewhere between them, okay? All right, so if we're going down, quarter of a circle is negative 90. Too small, keep on going. Subtract another 90, negative 180. Too small, keep going. Subtract another 90, negative 270. Too small, keep going. Subtract another 90, negative 360. Completed one clockwise rotation is still too small. Subtract another 90. You get negative 450. Too big, we gotta back off. So negative 390 should be somewhere between these two axes, the positive x-axis and the negative y-axis. All right, so let's draw our terminal side. It's going to be right here. Okay. All right, so let's see where. Let's draw our angle, indicate the area we swept. So we're going to go in this direction like this. We made a full circle and came over once. All right, so this right here is negative 390 degrees, or negative 13 pi over 6, and that is also theta. Okay. All right, what quadrant is the terminal side? It lies in quadrant 4. All right, remember the naming system. This is 1, this is 2, this is quadrant 3, and this right here is quadrant 4. Okay. All right, now let's move on to the C part. We'll have to find the reference angle. The reference angle. Okay, I'm going to call it theta reference. Okay, so to find the reference angle, we are basically going to look for the angular separation between the terminal side and the closest x-axis. Okay, this is the closest x-axis. So what's the degree of separation between these two, between 360 and 390? Remember, we don't care about the signs because the reference angle is always positive. Okay, so to find theta reference, all we just simply do is we're going to go 390 minus 360. Okay, 390 minus 360 is 30 degrees. So there goes our reference angle in degree form. Theta reference in our radian, we have to multiply 30 degrees by a convergent factor. We have two choices again, either pi over 180 degrees or 180 degrees over pi. Okay, so which one are we going to select? Since there's a degree on top, we'll pick the one with a degree on the bottom so that the degrees cancel out and we're left with a radian measure. Okay, so multiply here, we have pi over 180 degrees. Now the degrees cancel out. When we divide by 10, the zeros cancel out. 3 goes here 1, 3 goes here 6 times. If you multiply across, your final answer is going to be pi over 6 radians. Okay? So that tells me that theta reference is 30 degrees or pi over 6 radians. Okay? Now we'll take a look at the unit circle. We can indicate where theta reference is. This angle right here, this angle measure, is theta reference. Okay, that's a reference angle. All right, so there you have it. All right, let's go ahead and take a look at question number 2. So for question 2, same task. The angle under consideration is 700, let's call it theta. Theta equals 765 degrees. Okay? All right. So if theta equals 765 degrees, it's already in degree measure, so we need to express theta in radians. Okay? All right, so how do we do that? Theta in radians is going to be 765 degrees multiplied by a convergent factor. Let's express this as a fraction, 765 over 1. Okay, so let's see. We're either going to multiply by pi over 180 or 180 degrees over pi. Now, since this has a degree on top, we're going to pick the option with a degree on the bottom so that the degree cancels out. Okay, so we're going to have pi over 180 degrees. Okay, now the degrees divide out and multiply across. We have 765 pi over 180. Okay, now 45 goes into the numerator and the denominator. Divide by 45 top and bottom, and that's going to give you 17 pi over 4. Okay, so 17 pi over 4 is a radian angular measure of theta. Okay, so for part A, theta is equal to 765 degrees or 17 pi over 4 radians. Okay, so there you have it. Now let's move along to the B part. The B part here, we have to graph and indicate what quadrant the terminal side lies in. Okay, all right, so we're going to use the degree version to draw the graph because it's much easier to work with degrees. So let's draw our coordinate system, our x and our y-axis. Okay, all right, so what is the direction of rotation here? Direction of rotation is going to be upwards because it's positive. Okay, you always start your rotation, remember, from your positive x-axis, and then you determine the sign of the angle, and that determines your direction of rotation. So you have 0 degrees here. So since it's positive, we're going to rotate in that direction. Okay, remember, if it's negative, you rotate in this direction for negative angular measures. All right, so starting with 0, we're going to keep going until we find two axes that bounce this angular measure. So 0 degrees, keep on going, too small. 90 degrees, too small, add another 90, 180. Too small, add another 90, 270. Too small, add another 90, 360. Too small, add another 90, 450 degrees. Too small, add another 90. We have 540 degrees. Too small, add another 90. We have 630 degrees. Too small, add another 90. We have 720 degrees. We've gone 2 circles now, still too small. Add another 90. That gives us 810 degrees. Oh, that's too big. We gotta back off. So the terminal side lies in quadrant 1, okay? So this is where the terminal side for 765 lies in, somewhere here. Okay? All right, so let's see. Let's indicate the area, the region we swept to arrive at this. So we started from 0, we made a full circle, and went again before we ended up here. Bam. Okay, so we had to spiral twice, 360 and 720, to get this terminal side, which is, this is 765 degrees, or 17 pi over 4. Okay, 765 degrees or 17 pi over 4. 17 pi over 4 radians. Okay, so now listen, this is theta. The terminal side lies in quadrant number 1. Okay, remember, this is quadrant 1, 2, 3, 4. Now let's move on to part C, where we're going to be looking for the reference angle. Reference angle, I'm going to call it theta reference, like I did before. So what's the reference angle here? Remember, the reference angle is the angular measure from the terminal side to the closest x-axis, okay? The reference frame is your x-axis. How high or how low are you deviating from your x-axis, okay? This is the terminal side. The closest x-axis is a positive x. So the question is, what is the degree of separation from here to here, okay? That right there is your theta reference. All right, so we're going to be looking at 720 and 765. What is the angle of separation between those two, between this and this right there? All right, so to get that, theta reference is going to be, 765 minus 720. Okay, these are degrees. So if you minus these two, you will get 45 degrees. All right, so that's theta reference, the reference angle in degree form. Theta reference in radians, we need to do a conversion. 45 degrees over 1. So we're going to multiply by either pi over 180 or 180 over pi. Since there's degree on the top, we'll put the 180 degrees on the bottom so that the degrees will cancel. So this is what we're going to use, our conversion factor. The degrees cancel out like this. And then let's multiply across. We're going to have 45 pi over 180. Okay? Divide the top and bottom by 45. Divide by 45, divide by 45. And that's going to give us a result of pi over 4, because 45 goes into 184 times. Pi over 4 radians. All right, so theta reference is basically 45 degrees or pi over 4 radians. Okay, so there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. More videos can be found on mathgotserved.com. If you like this video, you can click like down here. I appreciate it. And please, please, please post a comment. Tell me what you think so I can make improvements to my videos. All right? Thanks so much and have a wonderful day. Bye-bye.